evaluate the limit. And we have the limit as x is approaching 1 of 1 by x minus 1 minus 1 over the natural log of x. So going right ahead here and evaluating, we will replace every x with 1. So this is equal to 1 over 1 minus 1 minus 1 over the natural log of 1. And we're left in both cases, we have 1 minus 0 over, 1 over 0 minus 1 over 0, which are both nonsense. These are undefined or indeterminate forms. So we are ready to apply L'Hopital's. And so we have the limit as x is approaching 1 of 1 divided by x minus 1 minus 1 divided by the natural log of x, and we're stuck. Well, we have two quotients here. We would end up with a determinant form if we used these. Notice if we applied L'Hopital's rule, we would end up with 0 minus 0. So we need to simplify the inside first. So we want to simplify this expression to a single expression. So I have the limit as x is approaching 1 of getting a common denominator here at the natural log of x minus x minus 1 all over the natural log of x times x minus 1. And now we're ready to apply L'Hopital's rule. So applying L'Hopital's, I have the limit as x is approaching 1 of the derivative of the numerator divided by the derivative of our denominator. So let's give ourselves a little bit more room. So in our numerator, we have the derivative of the natural log of x, which is 1 by x minus 1. And then to differentiate the denominator here, we need a product rule. So it's going to be 1, or the derivative of the natural log of x is 1 by x, and that's multiplied by x minus 1, plus we have the natural log of x, and multiplied by 1, and so it's safe to evaluate. We could simplify this further, but might as well check to see if it's not undefined first. So I'm going to replace every x with 1. So I end up with 1 over 1 minus 1 in our numerator. And that is all divided by 1 over 1 times 1 minus 1 plus the natural log of 1. So we're going to end up with 0 over 0. Rats! So we have this 1 minus 1 in the numerator becomes 0. In the denominator, we end up with 0. Natural log of 1 goes to 0. And we recognize this is undefined. It's nonsense. Right, which is going to allow us to apply L'Hopital's rule again. So I'm going to come back here, and I'm going to just simplify this limit first to make it look a little bit nicer. So I have the limit as x is approaching 1 of 1 over x minus 1. And this is divided by, if we go ahead here and distribute this 1 by x through to both terms, we end up with 1 over x times x is 1 minus 1 over x plus the natural log of x. And then since we're going to be applying L'Hopital's rule again, I'm going to rewrite this as the limit as x approaches 1 of x raised to the negative 1 minus 1 all over 1 minus x to the negative 1 plus the natural log of x. Right? And if you got a common denominator, that's perfect. That will work wonderfully too. This way I have little derivatives. So we apply L'Hopital's rule. And I have the limit as x approaches 1 of minus x raised to the negative 2 in the numerator, all over positive x raised to the negative 2 plus 1 by x in the denominator. And of course, you need to simplify this. So we have the limit as x is approaching 1 of negative 1 by x squared in the denominator, or in the numerator, all over 1 by x squared plus 1 over x. And to really make this look nicer, we have the limit as x is approaching 1. I have 1 over x squared in our numerator, and in the denominator we end up with x. Excuse me. We multiply the numerator and denominator of that second term by x to get the common denominator. We end up with 1 plus x all over x squared. We can simplify fractions in the denominator. We'll flip. So I have the limit as x is approaching 1 of minus 1 over x squared multiplied by the reciprocal of our denominator, x squared, by 1 plus x. And we see the x squared in the numerator and denominator will cancel each other out, leaving us with the limit as x is approaching 1 of negative 1 all over 1 plus x. And evaluating, I have minus 1 all over 1 plus 1, which leaves us with a beautiful final answer of negative 1/2.